All right, so today we have my friend Chetan Gupta. He is the head of AI research at Hitachi. And we're here because I want this industrial AI perspective to generative AI. And for those of you who aren't familiar, basically, industrial AI is essentially AI applied to manufacturing and other industrial processes. So ML, AI techniques to automate tasks, improve efficiency, and gain insights from data. So basically AI and machine learning, but applied to, I guess, physical world scenarios. So with that long-winded introduction, Chetan, welcome to the Data Exchange podcast.
Thank you, Ben, for inviting me. Looking forward to the conversation.
So as I said, we're here to get the industrial AI perspective to generative AI. But I guess, Chetan, as a way to set the scene for our audience, right? So for those who don't follow industrial AI, so how would you characterize just AI and ML in general, set aside generative AI? Before generative AI became a thing, what was the level of usage and adoption of AI itself in industrial settings?
Actually, that's an excellent question, Ben. So I would say it depended. So not just different industries, but different corporations within a particular vertical had different level of data maturity. And some were quite advanced, and we deployed some very exciting cutting-edge solutions for them. And some were just beginning to sort of on their AI journey, meaning they were setting up their data collection systems, having data collection, data governance policies in place. What I've noticed though is with generative AI, with sort of the huge attention ChatGPT sort of created, there's an acceleration of that process. Now more and more companies want to know how they can start on their AI journey and how they can incorporate AI into their sort of workflows and how they can use it to improve their top line and bottom line.
So again, for folks who are not familiar with industrial AI, so this is my kind of naive or kind of my, I guess my outsider impression, Chetan, right? So one, obviously high stakes, because basically if you make a mistake, it might cause injury or loss of life or something, right? So secondly, there's the interaction with the physical world. So a lot of data from sensors, sensor fusion, this sort of thing. And then finally, there's this kind of, I guess, because they're sensors, people who aren't working on these topics have the impression that we have so much data, we have tsunami of data, we can always build models. But it turns out that actually there's also model scarcity, because if you think of predictive maintenance, for example, right? So if predictive maintenance, if you are a good company and you build something reliable, then there's hardly any failure. So it's quite actually hard to model if it's a rare event. So besides these things, are there other things you want our audience to know about what sets apart industrial AI?
So I think when you touched upon the key points, so first is unlike sort of consumer-facing applications for us, the cost of mistake can be very, very high. As I said, can lead to injury, loss of life, and so forth. The other thing you also correctly pointed out that the data often is not as easily available. So I often talk about Hitachi elevators, right? So Hitachi makes elevators. Hitachi elevators never fail in the field. So it's great for Hitachi elevators. But as a data scientist, it's not so great because you have no failure data to model. And even the data collection, the cost of data collection is also high when you're collecting large volumes of sensor data from field equipment. So people typically used to collect data in an intermittent fashion. So maybe collect data during some 1 hour window in a day and then sort of compress that data and some signal is lost in that process. So the other thing I would say especially when you think about applying machine learning or AI to industrial applications, you have to think about your cost optimization. So for example, in machine learning community, we are very sort of comfortable doing false positive, false negative, and accuracy of your model. But if you think from a operationalization standpoint in an industrial setting, the model accuracy is not as important as the cost or cost of optimization, right? So for example, you want to bring your overall cost down. So if the cost of failure and cost of false positive and cost of false negative is not symmetric, what you in your optimization function, your loss function, that's what you want to incorporate. So you want directly incorporate the loss function itself in terms of costs rather than false positives and false negatives. The other thing I would say with industrial AI is that there is also a need for physical models. There is a higher need for explainability, right? So very often your model will interact with the human who is an expert in his field, has been doing a job for very many years. Now, if they're going to trust your model, then you have to be able to explain to them, why a model predicts something or says something that it does. And so explainability for us becomes also very important. So data, around modeling, there are several challenges. As you've said, the data is not often enough. We have to think about humans in the loop. And as I always say, real world is analog. And so whatever difficulties that entails, so that's what we have to sort of deal with when we try to operationalize AI machine learning in the physical world.
All right. So now let's go to generative AI, right? So as you stated in the beginning, the adoption of AI itself was all over the map, depends on the use case, depends on the company, depends on the division within the company, right? But then now there's a lot more excitement around generative AI, because I think this is true for all industries, because a lot of people can interact with ChatGPT, so they got excited about it, right? So what would you say, Chetan? So if you're a division within a industrial company and you were struggling with traditional AI, traditional ML, right? So how would you get started with this generative AI, given that you hardly have any success stories in AI itself? So what would be your advice? How would you identify use cases, or how would you proceed?
So one way I look at an enterprise is sort of set of core operations and then set of sort of support processes. So for example, if you're a manufacturer, then manufacturing, supply chain, these are your core processes. This is where a lot of your IP is. By the same time, you need the support process. You need legal, you need accounting, you need finance, you need HR. So, and very often corporations use some sort of software vendor for these applications, right? And these software vendors are introducing AI into their product. So I think the easier step, which is sort of to buy these services, is from a software vendor for your support processes. Now, when it comes to your core processes, that's where your core IP is, that you have honed sort of the art of managing your inventory, for example, in supply chain management. And that's where you need to sort of partner with someone who has experience in building these solutions. And then they can sort of tell you where in the generative AI roadmap are you, and what, depending on data that you have, the business problems that you face. So those are two boxes. The third would think about it for your products and services. How can you introduce AI into that, generative AI into that? And very often what people are beginning to sort of do is build some sort of a voice interface, some sort of a language interface to the applications. And so that's where a lot of people are starting in the generative AI journey. But if you think about those 2-3 boxes of applications, then I think you can sort of begin to make a decision in terms of a strategy, whether you want to buy, you want to acquire, or you want to build yourself. So I think that's how I would sort of recommend starting on the generative AI journey. And the other thing I would say is, once you sort of begin to think about AI, maybe generative AI is not the only place to start, right? So so-called traditional AI now, or cognitive AI, whatever is being called these days, they have a lot of low-hanging fruit for you to sort of pluck and benefit from. Simple things like demand forecasting, simple things like predictive maintenance. So there's so many other things that you could do even before sort of embarking on generative AI that can bring substantial benefit to you. And in many cases, especially in the industrial space, these traditional AI models have sort of proven to be successful and they have more of a track record. And maybe it might make more sense to start there and then sort of think alongside that about your generative AI journey.
So as I said, right? And as you hinted, right? So the level of adoption of traditional machine learning and AI was kind of depends on the company, depends on the division within a company. So now I would imagine the companies across the board, you've got executives telling them we should go towards this generative AI. And then someone in this team will say, yeah, we're building this forecasting tool or something, right? And then the manager will go, well, can't we just use the, chat GPT to build that, right? So what's the nature of conversations taking place right now between teams who are building and their managers in the industrial domain?
That's an interesting one. I think there is a lot of back and forth and a lot of disconnect. So as you correctly sort of pointed out, there is a pressure from the top to sort of say something about generative AI. And the sort of pressure sort of goes down the stack from top to bottom. And people sort of are trying to figure out how to use generative AI. And very often, not very often, sometimes there is sort of this mismatch of what generative AI can do and what people imagine it to be able to do. So things like, for example, demand forecasting. So demand forecasting is a classical time series modeling exercise. And there's so many mature models to do it. And there's sort of decades and decades of research in that space. And maybe generative AI can be used to build an interface around a demand forecasting model. But the core modeling has to be, as you know, around with time series data. So I think there is this sort of a back and forth going on. And the other thing I've noticed, especially in, we call them OT companies, is trying to find out where the highest ROI is. So many of these OT companies have very sophisticated sort of CTOs and leaders in the organization who are also taking a pause and trying to really see where the most benefit of generative AI is. So the use cases that I see very often, the top three, is around software development. So many people don't think, but a lot of the OT stuff that we use has a lot of software into it, right? And so there is around things around software generation or software around software writing, code writing. Then the other one is around customer support and response. And people are trying to be slightly careful with those and not letting them into the wild, but sort of testing them out. And the third one is around general knowledge management, right? So those three are the top three use cases that I see people sort of gravitating towards in the industrial space. And I think this could be very similar to sort of the broader enterprise space as well.
So earlier in the conversation, I brought up, and you kind of added to some of the industrial AI specific challenges to traditional AI and traditional ML. So when it comes to generative AI, I would imagine there's similar kind of challenges that industrial AI folks are most concerned about.
Yeah.
So I can imagine, for example, latency is one thing, right? So latency, hallucination. Hallucination is something that everyone cares about. But definitely latency, probably cost, right? So if you're going to deploy this
Yes.
at scale, and can you deploy it in maybe hardware settings where you don't have the latest and greatest GPUs and things like that, right? So what other industrial AI specific challenges are faced by generative AI?
So I think in a recent sort of design, we identified three challenges, and one we call reliability. And it's sort of not just around hallucinations, but it's also being being consistent, right? So for example, if you take a model and you ask it a question and it gives answer A today, and 2 days later you ask it the same question, at least in the human mind, and gives an answer B that is different from answer, very different from answer A, the human will sort of begin to lose confidence in that system. right? So reliability is about hallucination, it's about consistency. Then security is also a big concern to us. So in
Or
some sense,
also, that
um,
Chetan, in that case, is also maybe some level of setting expectations in education, right? So
yes, exactly,
telling
exactly,
people
exactly.
these
Yeah.
are models that are stochastic and creative, and even if you set temperature to 0, it may still do strange things.
Strange things. And I think, and there, partly, I think the news media around us is creates this impression of generative AI being so also powerful, right? So there is this, as you correctly pointed out, there is this step around educating the users of these systems on what are the limitations of this. So one is around reliability. The other, you correctly said, is around cost, right? Example, in a manufacturing setting, if I'm using a language model, does it really need to know about, the Taylor Swift, for example? It doesn't really need to know that, right? So can we build these domain-specific models that are much smaller to use? The latency is much lower, the cost is much lower, and they also incorporate your domain data. So I think another concern in enterprises, industrial enterprises, a reluctance to share their data with these large language models because they're not sure how the data will be used. And I think some incidents in the early days of generative AI sort of have put people on the alert. And the third, I think, is complexity of task. So meaning that we want AI to do much more than simply being a Q&A system. So can it do orchestration of complex tasks? Can it behaves like an agent? Can it behave like an agent in some form or the other? So at Hitachi R&D, these are the three axes around which we are sort of working with sort of language models in terms of making them much more usable. Now, the other focus areas around multimodality. So, for example, our multimodality is not just language and images, but language and acoustic data, for example, sensor data, time series data, event data. So there are other data modalities that are very important in the industrial space that we need to bring to bear on these foundational models or generative models. So that is another sort of area of interest for us. And then around applications, right? What kind of applications can we build with generative AI? And we did a very interesting study around supply chain of looking at the applicability of generative AI in supply chain. And it turned out that of, I don't know how many odd cases we had, a small percentage were pure generative use cases. The second larger bucket was use cases where generative AI or these foundational models behave in a traditional NLP function, right? So they're doing some sort of NLP. And the third, the biggest bucket was where generative AI was combined with other AI-based methods. For example, generative AI with simulation, generative AI with the methods to really solve these core industrial problems. So those are some of the axes around which we believe we need to make progress for generative AI to realize its full potential in the industrial space.
So, speaking of foundation models, so obviously there's the foundation models that are proprietary, right? So you can think of Claude or GPT-4 or Gemini, or now even the Mistral model is somewhat proprietary. And then there's the open source models like the smaller Mistral models, Llama, and so on and so forth. Is there a move within the industrial AI space to either take one of these open source models with the right license and kind of fine tune or build on top of those? Or is there even a more ambitious move, which is basically let's just do our own foundation model from scratch?
Yes. I think you will see both these things. And even Hitachi, we should have doing both these efforts. So we're taking some open source models and training them, or doing sort of additional pre-training and fine-tuning with domain-specific data to see if we could get domain-specific models. And what we see is that there is clear performance gain. So a smaller model, which is domain-specific, is able to compete with a much larger general-purpose model for industry-specific tasks. So clearly there is sort of that line of attack. And then, as I said earlier, we're also looking into now building these foundational models for other modalities of data, like acoustic data, like time series data, that we encounter in the industry. And also, if you think about even vision-based models like Gemini 4, they're very powerful, but I'm not, and they're close, right? But what if I have industrial data, image data, right? So do I need some questions that are still not answered is do I need a very general purpose large model, or can I build industry specific foundational model for vision as well, or vision plus language? So these are some of the things that yes are very interesting, and my strong belief, Ben, is we will not realize all the economic benefit of generative AI, of AI, unless we are able to successfully introduce them into the industrial world, into the physical world. And so that's where the real value is. In fact, this is something that was discussed by, I think, Satya Nadella and Jensen in one of the, I think, Microsoft keynote. Maybe I'm not sure, but I think this is clearly true. And to me, and we have been on this industrial AI journey for such a long time. And to me, I still believe in that, right? So that's where we'll do the most benefit to the society, most benefit to the world around us when we're able to use AI for these things.
No, I think actually, I'm of the opinion, I mean, I think in 2023, right? So 2023, maybe our focus was on the best model, best possible model, because people were coming out with models. And then people realized, okay, so the models themselves are largely interchangeable, or there's no actual distinction as far as model providers in the following sense, right? So if model provider X comes out with something cool, 2, 3, 6 months later, model provider Y can do something similar.
Yeah.
So
Very
then
true.
it all comes down to efficiency. So anyway, yeah. So now I've come around to the efficiency is the main thing, right? So which is basically you have to be efficient in marshaling your resources, because things change, right? So in other words, if you're a model provider, and you can see this, Chetan, now with the foundation model builders, right? So they're increasingly emphasizing computational efficiency because, one, they save money, but also that means they can retrain more often as more developments, more new ideas come to bear. And since the training runs are expensive, they can conserve resources as well, right? So I think increasingly that's going to be true even for users as well, right? So you're going to have to be conscious of the fact of how you deploy and how you marshal these resources, and how you use them. So I think that what you're saying about people focusing in on domain-specific models that are efficient, that are really targeted, I think that's increasingly going to be the trend, because it's almost like we started out where we had the kitchen sink and we were throwing the kitchen sink against everything. But now we're realizing, yeah, the kitchen sink will work, but it's just too much to carry around everywhere, right?
Yes. Then that is spot on, and especially in the sort of the enterprise industrial world, the cost ultimately becomes very important, right? So earlier, when you're doing POCs and so on and so forth, then sort of it's okay to sort of dabble with very large models. But when you start deploying them, start using them in the field, then the ROI has to make sense. And so there, things around the efficiency of your inference, even the cost of the model, those will become important. So, and I also touch upon something that you said earlier, is around these very large models, and I think there is sort of movement towards that as well. So, for example, I think just today, Aramco announced a large industrial model. I don't know what it means. It's just a news clipping, I guess. I saw it says 270 billion parameter model trained on 1 trillion data points, something like that. So I think you will see a movement towards industry specific, or industrial large models. I don't know uh, which direction that will go, meaning how successful they will be, or whether that would be better as opposed to a domain specific model. So those discussions will play out, I think, in the near future.
But even they, even you can imagine even if you have a ginormous industry specific model, you'll still probably want to use a mixture of experts so that you know you don't need that ginormous model
Yes.
if your task is so specific, right?
Yes. Yes. In
Um,
fact, the discussion that I've been having is, can we go from general to domain specific and task specific? And this hierarchy of models is, I think, what will be eventually operationalized, where rather than going to this mother law model for everything that you need to do, you go to the right sort of root or leaf node in the tree, and then figure out this is where I have the most ROI. So it might not be, and in fact, sometimes you can trade off between performance and efficiency, right? That's we've always done that in engineering, right? So if depending on the use case, how and that's where, in fact, another sort of piece of work that is very important is building the set of infrastructure around language models, around these AI models, right? It's not just the model itself, right? How do you clean the data that goes into the model? How do you build the guardrails around the model? And how do you sort of operationalize them in a sense, in a way that till they're completely automated, till that point we still need humans in the loop, right? How do humans interact with these models? What is the right way to design that interaction so that you get the most benefit from these models? So all these are some very sort of practical real world problems that we need to sort of address.
that's why I actually, I mean, if you're kind of one of these sophisticated teams that you had experience doing traditional ML, you knew that the traditional ML was a complex end-to-end pipeline with a lot of QA towards the end and monitoring after the fact. That's maybe you can take on this more ambitious scenario that you and I just painted. But if you're just beginner team, I mean, I guess the hello world applications like RAG, maybe you can
Yes.
start there and maybe you don't even need your own model. Maybe you can just use a API endpoint, right? So
Yes.
there's
Yes.
many ways to start, but I think the more you dabble, the more you realize this actually is still ML in the sense that you still need, as you point out, Chetan, these pipelines, the QA after the fact, which might now involve red teaming
Hmm.
and things like that. But I guess what I want to tell our listeners is don't get too intimidated. There's baby steps you can do, right?
Absolutely. And I think the best way, as always, is to just take the first step and then put your first foot forward in the next one after that. And I think there's so many libraries available and infrastructure is quite democratized. And I think your advice of starting with RAG is, I think, spot on, right? Just start with that. Or just start with prompting first and then try some structured prompting and then go to RAG. And by that time, you'll be quite familiar, at least with how these things work. You'll get a flavor of it. And then you can sort of think of slightly more complicated things in terms of deployment, in terms of building domain specific models and all of that. But I think the best way to get started is to get started.
So it seems like RAG is a good place for industrial AI as well, because you can imagine if I can do a RAG on a user manual, you know,
Hmm.
everyone has like a refrigerator, right? And
Yes.
then when you have to look it up, you have to go online and
Yes.
and download the PDF for your refrigerator and figure out what's happening. But you can imagine at some point the refrigerator will have a chip with a rag in it, and then maybe you can just talk to the refrigerator. By the way, I have a friend who's working on this.
So that's actually pretty neat. I think one challenge would be to
Pete
sort of convey
Warden.
the schematics.
Yeah, yeah, yeah. So yeah, I don't know how far along they are, but they have the technology to do it, useful sensors.
Hmm.
Um, but
Wonderful
yeah,
idea.
but because the manual isn't actually that big,
Yeah.
right? So
Yeah.
it's
Yeah.
kilobytes, right?
Yeah.
So and now they have very very slimmed down LLMs that they can go. put on low-powered processors that can work. So that's one idea. So by the way, so one couple of technical topics I want to check in with you, which is in the industrial AI, right? So we talked about data scarcity.
Mm-hmm.
So what do people in industrial AI think about generative AI and its potential in synthetic data?
That is actually a very promising sort of field for us. So I'll give you an example. For example, say you're doing a defect detection, or you're doing some sort of disaster scenario preparation for a government. So obviously, this data is very scarce, especially the latter one, right? And the hope for us is that we've used this at least for defect detection and a bit for disaster recovery as well, is to generate this image data using generative AI, and then use this as sort of the base data for you to train your machine learning model on. And I think there is, to me, this combination of data generation in the right format with generative AI, and then using sort of uh, traditional AI or even symbolic computation over this data could be a sort of very promising approach. There was a very interesting paper recently on proving theorems in planar geometry, I think, using some combination of data generation plus symbolic computation, which I think is very, very, very interesting. And I think so those lines of attack are also going to become quite interesting.
So you can take this forward into the science fiction realm, which is basically you start out with synthetic data and then you start building digital twins, and now you put on an Apple headset and now you're in the metaverse.
Yes, yes, yes. But metaverse is something that we're doing right now, especially I think where generative AI helps in metaverse is now we embed this data into the 3D space. Right? Suppose you go into a factory and you want to know what's
You
happening.
mean the synthetic data?
No, no, you mean the real data.
Real data. Okay.
And now you use generative AI to enable a conversation between the human and the metaverse.
I see.
So we are seeing application generative AI in metaverse as well, and it's sort of turning out to be quite cool in some sense.
Oh, very cool. So the other topic I wanted to check in with you is so because you talked about coding. Oh man, I imagine there's lots of coding applications in industrial AI, given all the obscure kind of software drivers and programming languages that in kind of the legacy systems, right? So set that aside. So one area one area where coding is used a lot is actually text to SQL, right? So
Yes.
and the reason I bring it up is because in the text to SQL world, the nice thing there is, SQL, it's structured query language that's used to query a database, but the keyword there is structured, so you have something to work with, the relationships, metadata, and then so what people end up doing is at some point to make the text to SQL system even better, they build a knowledge graph so that then the text to SQL somehow performs better. And in that context, it seems like at least people have something to work with in order to build a knowledge graph. So long-winded question here, Chetan, but what's your take on knowledge graphs? And I think to me, I have no evidence, right? So, but I do know that for RAG, even simple metadata helps, right? So,
Yeah.
so I think it's fair to say that a knowledge graph would help your RAG system. The only question there is how do you build a knowledge graph, right? So
Yeah.
how do you think of so in the extreme case, how do I take a bunch of PDF files and somehow automatically derive a knowledge graph? That's
Yeah.
not clear. But then, on the other hand, like I said, simple metadata helps. Maybe you shouldn't aim for a perfect knowledge graph. Just even the simplest knowledge graph
Yeah.
will help your RAG system, right?
So I think you're hitting on something very important and very interesting, Ben. So one way to improve uh, uh, around hallucination is to give some structure to the data and then query it. right? So that structure, as you said, can be sort of in a
Yes,
SQL table,
or
or can
simple
be a knowledge graph. And
simple
yes,
metadata like
yeah,
dates, right? So
exactly.
if you have some dates, then you ask a question, last month, what
Hmm.
so and so? And so then since you have metadata, then obviously
Yes,
that will
exactly.
improve, right? So yeah.
And people are building knowledge graphs in two ways, both automated using some sort of vocabulary. That's
Do those do I mean that's researchy though, right? Is that do you
that
think
is researchy.
yeah,
And then people also do it manually.
yeah.
So humans do it manually. And then and then the other thing that we have done recently is, if you think the abstraction of graph, it's very useful. So we build what are called um, fault tree diagram, right? So this is especially useful in maintenance. So if this happens, this is done. If this has happened, this is done. And these are somewhat compact, can be easily verified by a human. So we use generative AI over manuals to construct these fault tree diagrams. And then we build a RAG model to query the fault tree diagram itself rather than go to the manual. And then you can ground the data, you can do grounding and all sorts of good stuff. And that system becomes much more reliable than sort of directly going to the manual. So this notion of having an intermediate structure uh, when using RAG is a useful concept.
So you're saying that the fault tree creation can be automated.
Yes, it took us a lot of effort, but it was primarily we came up with a pretty neat structured prompting technique to extract the fault tree from the manual, and then we verified it with the domain expert, and then we deployed RAG on top of that, and that system became quite useful.
And then but then this is a one-off, or has this been replicated
So
by you in another kind of scenario?
so we are doing that now. So we did that for one product line, and now we're replicating it to other product lines.
And so this is structured prompting. And
Yes.
so the prompts, the structured prompts from the first scenario
Hmm.
works to create the fault tree for the
I
second scenario.
I would say, just like with everything generative AI, nothing works out of the box.
But there's
But
enough learnings from the first
yes,
scenario that
yes, it
simplify the
gets you close. Yes, it
yeah.
gets you close.
Interesting. Interesting. And so
Hmm.
then um is that work something that you guys have published
No,
or
we have not published that yet. But if you think that's of interest, I can ask the team to publish something on archive. Maybe
and
we will
then
publish it soon.
and
Hmm.
wh- what other use cases or scenarios besides what you guys did
Hmm.
do you think this work would be applicable to?
I think the other example that you said, right, creating metadata around your structured data and then querying with that, that I think is going to be one method people use to reduce hallucinations.
No, but
And
this fault tree creation work, where
this fault recreation work is,
who
I think, very broadly applicable, right? So if you think of, so one of the things in industry is that a lot of our manufacturing lines are bespoke, right? So it's not that I can buy an exact manufacturing line if I want to do something. And even within a factory, there are different variations uh, in the design of a manufacturing line. So if something goes bad, very often the operator or the maintenance guy will have to figure out what to do. Takes time. So if for each of these things you can create a fault tree from all the manuals that are related to the system, then this becomes a very broadly applicable problem. So I think this problem itself has very broad applications across the industry. And this is essentially serving a pain point. So trying to debug what's wrong, and sometimes there's a loss of production because your line is down and the maintenance guy is taking time, he's busy somewhere. But if you could have sort of a very trusted system where the operator himself or herself can query some sort of a backend system and say, this is what I see, this is what I observe. And you can even couple it with some sensing device. That's other part of the project that we're doing right now. And then it can really reduce the time to repair. And so this, I think, is at least in my expectation, a very broad and very widely applicable use case.
So Chetan, you mentioned earlier, so explainability, which makes sense, right? So this is something that pretty much is true across the board for many enterprise applications. So what other aspects of responsible AI are you focused on besides explainability?
So in fact, what I've been emphasizing the team is the term reliable AI more than responsible AI. And I give the example very often of a motor, right? So Hitachi has, it started off as a company that produced the first 4 horsepower motor for Japan. And a modern car has so many motors. So you sit in a car, you press a button, the seat moves, the mirrors move, and all of that fine stuff. And you don't think about it because a motor always behaves in a certain way. When you press the button, right? So my sort of emphasis to the team is, can you make AI that reliable? Right. So when I press a button, it always behaves in the same way every time. And when something is about to go wrong, it will create some sort of an alarm. It will notify me saying, look, under these environmental conditions, I'm not supposed to come. I'm not supposed to, you can't expect reliable behavior from me, right? When you get a product catalog for industrial equipment, it says under what temperature conditions, under what environmental condition it works, right? So can we get AI to that point, where when I buy an AI solution, it tells me, look, under these conditions it works, under these it does not work. So, and let me sort of pose a question to you, Ben, and see where you land up on. Suppose you have 2 AI systems, okay? And one is, and you have 100 examples each. One is that is 80% accurate, okay? But you don't know which 80%, but it is 80% accurate on average. The other system is, it is, say, 99% accurate on 60% of the data. And on the rest, 40%, it will tell you, I don't know. So which one will you operationalize?
Obviously, system 2.
System 2, right? But the challenge in machine learning is we have been focusing on system 1.
Yeah.
Right? We are always trying to maximize.
Because the leaderboards are system
yes,
1, right?
System 1. And in industrial applications, we need system 2.
Yeah.
Because system 2 is very valuable to me. Right. So in fact, can I find a region in the data in which I have a guaranteed performance, and then I'm good to go? The cost of operationalization becomes much easier to convince a stakeholder. So I think that problem, if we can solve, will take us a long way towards getting value out of these systems.
So in the case of generative AI, obviously these are stochastic models that are probably not likely to produce the same output, right? So even if you probably set the temperature to 0, might still produce different sentences, different images, slightly different images, slightly different sentences. So in your case, right? So in the user manual case, I guess at some level, I don't care what the exact sentence is, as long as the content in the advice in the sentence is somewhat stable.
Yeah. Yes.
Right?
And that's where the fault tree really helped, because now you're not querying the general data, but the fault tree is curated by humans. You're picking the answer from there. And you can also show which part of fault tree you're referring to. So human does not just get the answer, it also gets sort of the referral and the image of the right part of the fault tree. And that really helps in sort of addressing that question of reliability.
So Chetan, what about the other aspects that in traditional industrial AI, right? So sensors and real time and all of these things, right? So now you're in generative AI, and then the notion, the kind of the holy grail in industrial AI is self-learning systems that do sensor fusion, multimodality, and then would learn from new data. Because now, I mean, I guess in the science fiction realm, you can imagine you folks, you have all this sensor data that are not human created. So at some level, somewhat nicer to work with than the human generated data, right? So sensor data, and then you have a generative AI foundation model that somehow continuously learning and then ingesting data. This is kind of the science fiction scenario.
No, but that is actually a very interesting problem that you point, and this is something we've been thinking about. Think about, say, a large mining company, right? And it will have a large number of, say, mining trucks. And these mining trucks will come from different vendors. And within a vendor, there'll be multiple models. And with the multiple models, multiple year make, right? So now, so you have to think of a model that is at some point a mother model and is going through this hierarchy of make, model, year, components. It is able to tune itself to that particular equipment without me having to build a model from scratch for every equipment, right? So can I do that? So can I take a base foundation model, and then as it experiences the real world through the sensor data, it learns to sort of be better and better and better for that particular equipment that's in the field, right? So that is one of the areas of research that we're working on as well. And that to me is very interesting problem. The other holy grail is at the other end. And where can I now do optimization, end-to-end optimization of very large systems, right? So a system has, think of a manufacturing line, motors, equipment in a manufacturing line, multiple manufacturing line connecting to my inventory, connected to my sales, connected to my sort of demand forecasting. Now, with all of this, can I automatically sort of do an optimization for the whole plant and make decisions at the whole plant? So there are a number of very exciting, sort of very challenging problems for us to deal with in this space.
So last year, the BUSSY term was co-pilot. This year, the BUSSY term is one that you already used in this conversation, which is agents, right? So now you in your case, I mean, in the industrial AI case, I mean, I imagine there's so many possible ways you can benefit from having agents that actually work, right? Agents that can actually go around and do complicated tasks, series of tasks. But now we're thinking now in our discussion here, right? So even a simple task may require multiple LLMs, where you have a routing model choosing the right LLM. Now you can imagine a directed acyclic graph of LLM because now you have an agent. Now maybe we're starting to get more, Chetan. I don't know if I'm getting too excited here, but maybe now we're going back into control theory here.
Yes, so I always Hitachi works in nuclear space as well, and I always tell people, please don't use AI in nuclear power plants because so I think I'm not confident enough to use AI for control systems.
I'm just looking 20 years.
20 years from now. Yeah. But I think certainly these agents sort of running around, doing their own stuff. And I think you will have to sort of start thinking about all sorts of things that we think about humans, right? Who has access control? What is an agent allowed to do? And how do you reprimand an agent, for example, right? So these things become very interesting when you think.
But and then what are the lessons from optimal control and control theory?
Yes, exactly.
Because those are things that we know work. They fly planes. They do all sorts of things, right?
Yes. That's actually very true. But the way we're starting out in this journey is simply using generative AI as a tool for process transformation. So if you think about it, right? Any industry runs on processes, and very often they're not tabulated. They're not encoded anywhere. Now, can we use generative AI to extract from human conversations and other documentations? Can we extract the process diagrams? And then once you have extracted the process diagrams, now you have a base to start thinking about transformation. So I think for me, generative AI becomes a very sort of potent tool for organizational transformation. It's a very prosaic kind of use case, but I think it can be incredibly useful.
So in closing, right? So the basics from AI to generative AI, the basics remain the same, right? So you have to find the right use case. well, you have to ask kind of the basic questions, right? So, do I have enough data? Does this task deserve automation? In other words, do I have enough scale to actually justify automation? And do I have enough data to actually
Yes.
develop an automation model? So a lot of the basics remain the same, but now you have models that are maybe more opaque, I guess a lot more flexible, right? So
Yes. More
uh,
powerful,
more,
more generalized.
yes, yeah. But then maybe not as performant as what you guys are used to in the industrial space because you want blazing speed, right?
Yeah. Yes.
So, but as we pointed out, you know, you can't get too intimidated. You have to start slow. As Chetan points out, pick a simple use case. Maybe RAG is the right place to start for most people. And then I'm hoping you guys publish this work on fault tree automation because that seems like a really powerful piece of work right there. Um, I don't know to what extent, what level of out of the box you can make it work, right? But
Hmm.
even with some level of automation, it'll be incredibly useful to so many teams, not just in the industrial AI space, but everywhere.
I hope so too.
Yeah.
Yeah.
And
Yeah.
then the all the concerns that you have with traditional AI, don't forget about them either, right? So security, privacy, bias, all those things matter. But
Reliability,
yeah,
all those things continue.
I mean, I think this is the nice thing about having Chetan here. I think we don't talk enough about reliability because I think in their case, in the industrial AI case, that's almost like a first order requirement, right?
Yes, it is. You want reliable systems.
Yeah.
Yeah. Yeah.
And so with that, thank you, Chetan.
Thank you, Ben. This was wonderful. Thank you so much.